Thank you for choosing my talk and coming to this room. You're all awesome. It's you know, let's make them, like you said, jealous. The other room, right? I say performance, and you all say yay, right? So 1, 2, 3, performance, yay! Fantastic. All right. So this talk is mostly about performance, like making up much more faster, especially in React, and give our user better user experience. So how many of you actually have seen this page? How many of you actually have created a website or web application that causes this page? How many of you not have done that? But then what of the rest, though? What are you? Some people didn't raise the hand at all. All right, so we're going to talk about this. And you know that sometimes it happens, you see it and you click, and then suddenly some stuff doesn't work, and then suddenly they work like repeatedly, very fast. And that's the time where our user is very frustrated, you know, especially including ourselves. So we're gonna have today. We're gonna explore different options today. We're gonna talk about parallel computing versus concurrency. I know that the React also has a new experimental mode right now called concurrency mode. But this talk is can be you later can understand how they are implementing stuff. But this is mostly about new APIs in the browsers, like web workers. This is not new, but WebAssembly, Worklets, and Service Worker. So what I'm trying to do in this talk is I just want to make it so practical. So I want you to go out after the talk and then open on your laptop and try to implement right away. No theory, no boring stuff. Just practical stuff and implementing code right away. So before that, let me introduce myself. My name is Majid. I'm flying from Oslo. I'm a passionate software developer, just like all of you. And in my spare time, I'm doing a lot of stuff. My hobby is running conferences, meetups, and leading the communities. It's very interesting to me. Also, I've written a book about progressive web app, but about our enemies, Angular. Don't worry. And I mostly talk about performance, PWA, progressive web apps, and Flutter. So let's get into that. What is parallel computing? When we are talking about parallel computing, we're talking about multiple entities that they are doing different tasks, or they are working on the same task. And compared to concurrency, when we are saying concurrency, that means we have one entity which is working on different tasks. Like these pictures are self-explanatory. So how does it work like in the browser? We all know that in the browser we have single-threaded JavaScript running in the main thread, right? Everything is only in one thread. And that's a bottleneck. And how it works? The way that it works is that we have event queue. We have a lot of events queuing in this lane. And then they execute it, getting completed, and then go away, and the next one comes. So that's where the problem starts. When we have a long event happening, then everything is blocking because the event needs to get completed before we move on. But what kind of option we have to solve this problem? The first option is gonna be web workers. So web workers are around for around maybe 10 years or so. How many of you know about web workers? Almost everyone, expected. And how many of you used web worker? Less than 10%. And I'll show you why you don't use it, and hopefully after this presentation you're gonna use it. So we know web workers that they in browser they spin up a new another instance of JavaScript engine, and then you have a different thread and it runs everything there. And the way that it communicates with the main thread is via the messaging system, right? And this is how it works. So you have your browser event queue and you have your web worker message queue. You send your message to the web worker. It takes care of your events execution, and then once it's done, it can come back again to the main thread. All right. So, but isn't it like this is a concurrency? Where is the parallelism? Well, different devices these days have different cores, like multi-cores, right? Nothing stops OS to run this thread in different cores. And that's when parallel comes in. That's when the parallel computation actually happens. But do we know that as a web developer? No. We don't know that, but it may happen. So let's get into some use cases for web workers. You can think of like very heavy computation in the browser. So you can hold up these heavy computation to your worker thread, get it to work, and then get the result back to the main thread. Like an example could be a very huge list that needs to be sorted. It's like blocking, right? If you use a for loop, it's blocking the main thread. So how it works, the way that it works is that you have main thread, you have worker thread. So you need to send a post message. In code, that means after you instantiated your worker, web worker, you're gonna send a message to the worker, as like this example. And then once you send the message in a worker, you listen to the message event, you get the message and react or execute the things that you need to do. Here's an example. And once it's done, you send back the message to the main thread. And on the main thread, again, you need to listen to the worker message, which is coming, and then get the result, and then do something. And for instance, set the state in React to re-render your UI. Okay, that's not very, very interesting. That's the reason 90% of this room doesn't use web workers. But can we do it better? Isn't it better, like, to get access to the function directly from main thread to the worker thread? Like, it's way easier, right? And instead of having all of these post messaging around, just directly call a function in worker thread. Yes, it's possible. That's where comlink library comes in. A library from Surma, a Google web advocate in which he actually created this library a few months back. So how it works? So in your main thread, you'll see that how this gets easy. In your main thread, you're gonna have, again, you need to instantiate your worker, but this time you just use comlink to proxy or wrap it. And then once it's wrapped, then you get access to your object or function which you exposed in the worker, and then you can immediately call that function. That's a promise-based function. You can await for that and then get the result. It looks like a synchronous way of programming, right? It's way easy. So in a thread worker, let's imagine now that I have, by the way, you need to import this package for sure. So in the main thread, I'm gonna have service and these different functions, which I'm exposing to the comlink, from the comlinks. All right, let's see in React how this could help one of our problems, for instance, in React application to make it smooth. So we we had a use case that we had like a 3,000 an array with 3,000 member, which we needed to sort. And this is very common use case, right? So it happens. There are multiple different approaches to fix the performance issue here, but I'm just going to not to optimize everything and try to use just a web worker to see how it works. So what we did is that we just wrapped our worker, which has the function to sorting the list. And it looks like when I click in a button, I just call the function from worker and get the result, which is a sorted array back to the main thread. And my worker here is simply a function, just has 2 for loop. Like I said, we didn't optimize it. That is on purpose. So let's see actually how it works. You see, when I click on ascending with web worker, my animation for that little circle, it doesn't stop. And it works. But when I click on the main thread to sort, then it blocks the UI. That means the animation doesn't work. It stops. And then it works. All right. Was it easy? WebAssembly. Why WebAssembly? Because it's buzzword. No, that's serious. I have some question here. So when I say WebAssembly, just say it loud. No, no. Exactly. When I say WebAssembly, what do you think? What is the first thing comes to your mind? Say it loud. Rust. Wasm. Pineapple. Mozilla. C. Machine code. I didn't understand what you said. Yeah. The one. All right. Yeah, you're right. Or maybe you've heard like WebAssembly is fast. We'll look into that. Maybe it's not that fast. But let's see. Generally, WebAssembly, you know that. The purpose is that you write different languages in different languages, and then you compile it to assembly that can be run in browser, right? And when we talk about WebAssembly, well, the first languages that it comes to mind is C, C++, and Rust, which they have a very good support for WASM or WebAssembly. So, but we as a JavaScript developer or web developer, let's say, maybe we are not very keen to deal with C or C++. I'm not saying that you cannot or we cannot, but that is not something we are used to it, right? So maybe there should be a better way to deal with that. And maybe that's the reason we are not going to use WebAssembly. There is assembly script, where we as a JavaScript developer, if we know TypeScript, how many of you know TypeScript? Then all of you can use assembly script. So in assembly script actually compiles a strict type of TypeScript to WebAssembly. So there are strict types for WebAssembly which needs to be only used in that assembly script, and then that can be compiled to WASM. So let's have a look. It makes it very easy for us to use assembly script. So how? First, when you set up your project for writing WebAssembly, you can literally download it from npm, first of all, and then you can instantiate your or initialize your application or create a new application, right? Then you get a bunch of folders and files, and everything is ready for you to write your WebAssembly code, your assembly script code. So here is where you can write your function. So as you see here, it's a very simple function right now. I wrote a Fibonacci recursive version of Fibonacci to test like how performance is WebAssembly, and I wrote it in assembly script. So it's a very simple function, and you see that I am using some of the type that are not in TypeScript. These are the type that are dedicated to the assembly script, to the WebAssembly. So there are multiple other types too, which you need to get familiar with that. And luckily, they are not that hard because we as a developer are familiar with most of them. You still need to deal with memory, maybe, in assembly script, but the way that you need to deal with memory in assembly script, it's very easy compared to C and C++ and other languages. And in a new, that's a news. In a new version of WebAssembly, which browser vendors are working in a standard, there will be actually garbage collection, and that means we don't even need to do this later when it comes to the browser. So, and at the end, when you wrote your functions or all of the things that you need, or maybe some converter, everything, the only thing that you need to do is you need to compile your assembly script to WASM, just with one command line. It's just npm run as-build. All right, so you get multiple files, and these files optimized are ready for production, and these are for debugging mode. So I have my WASM ready. Who has already worked with WASM? So, okay, you know that if you want to use WASM, if you want to instantiate WASM in the browser, there are some things that you need to do. And maybe it's not that interesting, or not. I'm not saying it's not easy, but it's boring stuff. But if you use assembly script, it makes it easy for us to fetch the WASM and expose it to the main thread here. So the only thing that we need to do is we need to import this function from this library loader, and then fetch your WASM and expose the services that you expose from assembly script. In this case, I had my two function, which Fibonacci one is my interest. So I also wrote a JavaScript version of that function. Surprise, same function without type. So the same function. So I wanted to measure like what is the performance of the JavaScript version compared to the assembly script version, like WebAssembly version of that particular function for me. So I did a measurement here. So here is where I'll show you the measurement shortly, but here is where I say, when we say fast, we don't have to accept it right away. We need to measure first. Maybe for that particular case, it's not fast for you or for me or for that particular case. So I did a measurement here. That was a very simple function, and I thought that, okay, let's do that. For this number, I ran two functions, and it was fast for the first time. When I ran the WebAssembly version, it was 7 times faster for the first time. But for the second time, when I ran the function, then the execution time was fairly similar, like very similar. So here is where I actually ran this for the first time. You see the time here, and without WebAssembly, the time here is around 7 times slower without WebAssembly. All right, so you know TypeScript, you now know some types, then you can write some of your logics and maybe some coder or something in assembly script now. And the third option, it's Worklets. Who know what is Worklets? Oh, good. Almost no one. Worklets are a light version of web workers, so immediately comes to my mind, okay, they run in a different thread, like a worker thread, right? So that's good. And what it does, it just gives us an ability to access low level of rendering engine, like a graphic rendering engine, like CSS engine, or audio processing engine. That is very cool. So that means I can do many things. I can get access to the low level engine and then do some stuff. There are multiple different worklets available in the browser. We have paint, animation, layout, and audio. Okay. Except paint, the rest doesn't have a very good support in browsers, but the paint API support is much better. At least we can start playing with that and run some cool heavy, like maybe animation in the browser. And let's look into that. When we say paint, I'm talking about CSS Paint API, and that is also known as Houdini Paint worklet. So let's see how it works. Like web worker, you're gonna have a different JavaScript file. You write your function to draw something, to render, like paint something in the browser. Like in this case, I want to create a checkboard and actually render it behind my background page. All right, that's cool. So I registered my paint. This is a simple function here to create that. And then here in my application, I just said, okay, please add this function for rendering the background to my application. And then when it's instantiated, I can have paint function, add my checkboard function to it, and then I get a background image. I just write my background image in JavaScript. Let's see in practice. This is how it looks. So the rendering, this custom background image is happening in a different thread. It doesn't even block the main thread. So I'm sure now you get a lot of other ideas like how you can use this API. So another cool maybe example here, which I did in React, is to generate this QR code on the fly without blocking the main thread. So I'm actually rendering the QR code right away with Worklet, changing everything. It doesn't block the main thread at all because it's happening in different thread. And as you see here, the animation is also always working. So that means my browser is ready for users to do whatever they want. And the last option, service worker. You may say, okay, service worker is not something dedicated to like main thread or maybe just React. Oh, yeah, you're right. Service worker is a bit different from others. You cannot use service worker directly calling or communicating with main thread. Maybe you're right. But why I am interested of service worker, I'm going to talk about it. Of course, I need to talk about it because I'm a PWA lover. So let's talk about it and see the use case of this web service worker. I call this brain of PWA, progressive web apps. Who knows what is progressive web apps? Good, fantastic. The more I talk, the more I see that people know about progressive web app, and the more they actually implement all of the functionality for that. That's awesome. So I have a full talk about service worker, which is linked here. You get the slide later. Don't worry about it. So again, it's built on top of web worker. So okay, a type of web worker. But the difference is that service worker, as you may know or may not know, it acts like a proxy, right? Okay, the proxy, it's interesting. What does that mean? That means the request and response can come to your service worker first, and then you can manipulate these responses or requests. But how can that help us to actually have some parallel computation? Okay, let's get into that. Let's imagine that we register a service worker. We have already a service worker registered, and we have everything set up. All right. We can do some stuff on the fly because you can catch the response and request, and then you can actually respond. So let's see here an example which a friend of mine did, Kenneth. So in this case, what was the scenario? You have, by the time that this example was made, there was only support of WebP in Chrome and no other browsers, right? Who doesn't know what is WebP? WebP is another type of image compression like JPEG, but maybe 30% more compressed, right? And also supports transparency like PNG. They wanted to use actually WebP, all of their images, because it was way smaller in terms of size. Okay, great. But what about other browsers? Okay, one option was like to load different file for different browsers, right? But another option was, okay, let's intercept all of the requests and see if they are a WebP file. And he used some libraries, C libraries, and he wrote a function that decode those files and respond to the main thread, like respond to the application with encoded of this WebP. So the application could actually show the picture, even though browser didn't support WebP. That is cool. So in Service Worker, well, it also runs in a different thread. That's good. So you can have WASM do this stuff and manipulate your response and return the response to the main thread. The sample code and link to demonstrate is also added to the slides. Let's summarize it. There was some bottleneck with web workers, which we now realize that comlink is a library can help us to make it easier to work with web workers. WebAssembly may not be easy to start working with C and Rust and those other languages. And if you don't have time to learn those languages, you already know TypeScript, you're going to start using AssemblyScript. Service Worker and Worklets, they are also different, running in a different thread, which can help us to compute different scenarios for us. And with that said, thank you very much for listening to me. If you have any question, I'll be around. Just catch me, I'll answer.